Okay, again, regarding the spirited flow, you want to make it as minimum as possible, right? That's why you end up having a streamlined body nowadays. Either in your car, your your aircraft, everything, you will try to make it as streamlined as possible, right? Even for a truck, okay? Even for a truck.
The greater the front surface and the more edges the body has, the greater its air resistance.
Now this is your truck. When you have this kind of truck, you have a big area of the wing, right? Inspiration will be like that. This one is your streamline.
The air resistance. Doubling the speed results in a fourfold increase in air resistance. Thus, at a speed of 80.
Now you can see here, this is the wing. Inspiration. Okay? This is inspiration on a truck and this is inspiration of a bus. So you can see, because this two vehicle is a bluff body, right? That's why the wing is as big as those. Okay?
55 kilometers per hour, 40% of the overall resistance.
This is your rolling resistance because of the tire, right? This is the air resistance, the drag into the air friction. So you can imagine if you have a velocity of our highway, 110, which is around here, the drag is 4 times the rolling resistance. So it dictates how much fuel is burned by your car.
Already generated through air resistance alone. Rounded edges at the front, wind deflector plates on the sides, and a roof spoiler significantly reduce the turbulence and therefore the air resistance. The aerodynamic potential that can be achieved without taking into consideration legal framework conditions is demonstrated by an example of the MAN Concept X fusion.
Nice, right? You can design a truck like this. So if you do this, you can see that the weight is very small and the tire is covered, so there is no weight generation in here. And over here you can see that this one is covered and the shape of those things is just like that. It represents, if you know the Tesla service truck, yeah, it looks like that. Right?
The key features are adaptation of the tractor machine and semi-trailer as a single unit, the aerodynamically ideal shape, reduction of the back pressure on the front of the vehicle, extensive side and underbody paneling, protruding components are minimized. For example, the mirror is replaced by a camera. Through optimization of the cab shape, it has been possible to reduce the air resistance for the TGX by around 4% compared with the previous TGA model. The better the design and adjustment of the spoiler systems, the lower the increase in drag in this area. In the further process, the side contour of the semi-trailer and the cab front in particular offer potential for reductions. Open bodies such as tipper troughs, platform bodies with angular cargo, or fissured special bodies, for example those in car transporters, cause a high air resistance. Depending on the driven speed, this can result in increased consumption of up to 15%.
Okay, so you can see now, even the truck, which usually is which usually don't care about the drag on it, now start to look at it because the fuel cost due to the drag is tremendous. It's 4 times the rolling resistance. Right? So it's very important. Okay, so that's why most vehicle now looks like this streamlined body, the water or the teardrop, right? The teardrop of water. Okay. Now another thing that I want to highlight to you is this: when you have a blunt body, right? When you have a blunt body, most of the drag is due to the pressure, which a little bit part is due to the shear. Okay, so when you have this kind of body, the drag is mostly due to the pressure difference between the top, the front, and the rear. The shear working on this side is marginal. Okay, but when you have a streamlined body like this, when you have a streamlined body, the drag due to pressure getting minimum, but the drag due to the shear stress getting more important. Right? Getting more important. That's why later on, when we look into the aircraft, the drag coefficient is not calculated based on the frontal area, but it will be on this area. Because when you are dealing with the streamlined body, this area is small, this area is the big one. And the force, the drag force is mostly due to the shear. That's why you get shear force getting bigger. Okay? Right? And then the other thing is the drag is depending also on the angle of attack of your streamlined body. If you have conduct experiment on wind tunnel, any one of you? Okay, the assignment or the experiment asks you to evaluate the drag force or the coefficient of drag when the angle of attack is changing, right? Positively and negatively, and you will get everything will change. I'm not sure whether the smoke generator is working on that wind tunnel. It used to be no, right? When it first came, of course it works. Nowadays no. You can have this kind of flow. So this white line is smoke from the smoke generator. Okay, that's why you get all those streamlines. Okay, when you have a vortex here, this vortex will generate a vibration. Because when you generate the vortex, the pressure over here will keep changing dynamically, right? So that's why sometimes if you are inside the aircraft, then the pilot say, okay, please fasten your seat belt. We have a turbulence, and then you get those things. That one is due to this small thing, right? This small thing can shake the aircraft. Even though your aircraft is very strong, this small thing can shake it up. Right? So those vibration is vibration due to the vortex. And it can be very dangerous if it has the same resonant level with your aircraft body. If you remember the Manhattan Bridge collapse, you know why is that? Due to the air. Can you imagine? Only air flowing at not even very strong, but it vibrate, then collapse. Okay? So why it's happening is because this vibration, if the resonancy of, if the frequency of those vibration is equal with the natural frequency of those design, right? If you have the same frequency, like your radio, right? You can hear the radio because something is there changing the frequency, then you get it there, right? The FM, frequency modulation. The same goes for that. When the frequency of this vortex is same with the frequency of your bridge, you will resonate. Then it will collapse. That's why you got those those problems, right? And it is mostly dangerous for the aircraft because the design of the aircraft is strongly depend on the aerodynamics of your wing. Okay, is how you can design an aircraft wing, especially so that you can have it fly. Okay, so for those, we will dealing with the lift coefficient. If you look at it, everything looks exactly the same, right? Previously, you have FD is equal to CD A half rho phi square. Now you have your FL is equal to CL A half rho phi square. The only difference is this. Okay. The other difference is this, the area. For this lift, the area will be the platform area. What is platform area? Is the area of the wing when we view it from the top. Okay, so imagine this one is your aircraft. You put it there and you look it from here. This is your wing area. If you go to Wikipedia, you search whatever aircraft, they will state clearly there what is the wing area of the aircraft. Why it is important? Because those wing area will determine your takeoff weight, maximum takeoff weight, the rating of your engine, and how long is the runway needed for your aircraft to fly. Okay, depending on that. The other thing that you need to learn is DCL, the lift coefficient. How do that thing important is you will see that the bigger the lift, right? If you look at this one, the bigger the lift, you can have a smaller area and smaller velocity to take off, right? Because if you want to take off, the lift force has to be equal or higher compared to the weight. So before you can take off, you need to have a minimum velocity. Okay? If you need higher velocity, you will need a longer runway because your aircraft start from stop, right? Before aircraft start to roll, it will stop and then it start to roll before you take off. Okay? And the engine of the aircraft, you cannot make it as powerful as you wish. Because when you have more powerful engine, of course, you will consume more fuel. And the bigger the engine, the bigger the drag. The bigger the drag, you need the bigger power to overcome the drag. Right? The bigger power needed, you need the bigger engine. Now, the bigger engine creates more drag. Right? The drag needs more power to overcome the drag. To get that power, you install a much bigger engine. Now, this becomes problem. Right? That's why you need to optimize it. Optimization is always there. Okay? So I will show you how we deal with it, and you will learn what is the component on the wing of the aircraft. So next time you hop on the aircraft, you know that this one is air brake, this one is slot, this one is winglet, and that one is flap, and so on. Okay? So we will learn about it in the next class.